In today's tutorial, we'll be looking at events on Tezos, what they are, what they are used for, and how to write your very own smart contract that emits events on the Tezos blockchain. Let's get into it. What are events? Events are internal operations that are emitted by smart contracts, allowing off-chain apps to subscribe to changes on-chain. So if you have a smart contract that has an operation or things that are going on within it, you could also have that smart contract emit an event that could then be picked up by a dApp, lives off the chain. And then broadcast the events or broadcast the results of that transaction to the dApp. And let's look at this diagram that we've got here. We've got an operation being sent to the smart contract. And when the smart contract receives the operation, the smart contract completes the operation and adds that transaction to the chain. And the dApp can get updated with the data that has been written to the chain without the user having to refresh the page. And let's look at a couple of real-world application of events. Now, events can be used for notification systems, or they can be used in building real-time systems. For notification systems, one example of that is you have a lending dApp, right? And users have come to that dApp to borrow some tokens. And you can send them reminders about upcoming repayments because you're able to receive that notification from the chain. You're able to receive details about that transaction or the amount that they've borrowed from the chain. And you can then use that information to notify the user when they have an upcoming repayment to make. Another application of events is in supply chain systems. You can always notify parties that are involved within the supply chain about the status of a delivery. So if you've got goods shipped out and that is being tracked on chain, we can always notify our systems off chain about the status of that delivery. And if we think about building real-time systems, one application of events on chain is displaying real-time information about NFTs, right? So if we have NFTs being sold and being transferred by creators and collectors alike, we could simply have all of those transactions emitting events on chain to our off-chain dApp, right? And our dApp can pick it up and always update the UI with the latest results. Now, what are we going to be building today? We're going to be building something to quickly demonstrate the power of events on the Tezos blockchain, and we're going to be doing that in SmartPy. Now, we're going to send a number to add to a smart contract, and this smart contract is going to take that number and it's going to add the number to a number that is already stored on chain. And after adding those two numbers, it's going to emit the results to our dApp, right? So once those two numbers are added, we emit the results of that transaction to our dApp, and our dApp gets updated without refreshing the UI. Now, I'm going to demonstrate an example of what we're going to be building today quickly before we get into writing the code. So I've got a front end of my application here, right here, and I am using this smart contract that was deployed here. So if you come to this smart contract and if you go to storage, we can see that the number that we've got here in our storage is 40, right? And I'm going to go under interact in the Better Call Dev UI. So remember, Better Call Dev is a smart contract explorer for the Tezos blockchain. And I'm going to come into Better Call Dev and I'm going to type, say 10, right? And I'm going to click on execute. I'm going to click on wallet here. So this Better Call Dev UI allows us to simulate transactions to our smart contract. And I'm going to click confirm. And once I click confirm and I come back to my UI, just need to give it a few seconds so that the transaction is written to the blockchain. We should see the UI here update. Yes, as you can see now, my UI has updated. So the number that we added was 10. And the stored value has been updated to 50. So now I'm going to go back to the SmartPy IDE and we're going to start to write our own smart contract that emits an event and picking it up on this dApp right here. So let's get into that. So the first step, as usual, always import SmartPy as SP, and then we're going to declare a SmartPy module, and we're going to create a class called events. This class is going to inherit from the SmartPy contract class, right? So SmartPy already gives us a contract class that we can simply inherit methods from and then start to use that within our smart contract. And we're going to initialize our class. To initialize our class, we're going to create stored value. So stored value is going to be a value in the storage, and we're going to cast it to a natural number. So sp.cast allows us to control the types while writing our smart contract. And then next step, we're going to create an entry point. And in this entry point, we're going to have a method called add. And essentially all this method does is it takes in a number to add, and then it adds that to whatever is in our stored value. And then it emits the number that we've taken in and also the number in our stored value to whatever app is listening out for that event. right? So we have, as you can see here, we've got our stored value, and then we're adding the number to add to that stored value. Now, we're going to call the sp.emit method. So SmartPy gives us an emit method that allows us to emit the results of transactions or emit whatever data that we want to emit to a dApp, right? Or to applications that are off-chain. And so as you can see, it takes in a type of sp.record, and then we pass source as well. Source is usually the contract address. So we pass the contract address first, and then number to add is the number that we're adding in here, number that we're adding to the stored value. And then we're also passing stored value as well. So you can see we're passing stored value here as the second variable to our emit method. And stored value is going to take a self.data.stored value, which is basically the number that we have in the storage. So we're basically passing the stored value in our storage to our emit method. Then we also have something here called tag, and we're writing add in here. I simply just like to have my tag as the same name as my entry point, right? So tag just allows you to identify which entry point is being called or which entry point this data is being emitted from. And then lastly, we just write very simple tests. This test is only just going to check that whatever number is added to the stored value is correct. So as you can see, when we add 2 to the stored value, we want the results to be 3. And if we run this, everything should run correctly. So if we add 2 to whatever is in the storage, remember that we initialize the storage here, or we initialize stored value with the number 1 here. And if we add 2 to it, we should have 3 as our stored value, which is correct. Now everything is fine, and the next step is to simply deploy this contract to the chain. And as usual, we're going to click on deploy Mikkelsen contract, and we're going to click deploy Mikkelsen contract again. I'm going to switch this network here to the ghostnet because we're deploying this on the ghostnet, and I'm going to select an account to deploy my contract with. I'm going to go to Temple because I've got the Temple wallet, and I'm going to sign in. Once I'm signed in, I'm going to select the first account here, and I'm going to click validate. Then I'm going to click estimate cost from RPC, and finally I'm going to click deploy contract. Accept, and you click sign. Our contract is going to be successfully deployed or originated to the Tezos blockchain. Now, once our contract is deployed to the Tezos blockchain, the next step is for us to write the front end of our dApp that would basically be listening out for events that are emitted from this smart contract address. Now I'm gonna navigate now to VS Code, where we're going to be writing a hook in React that pretty much just uses the Taquito library. Taquito is the JavaScript library that allows us to interact with the Tezos blockchain. The Taquito library provides us with methods that we can use to interact with the chain and to listen to changes and to events that are emitted on chain. So yeah, I've created a use Taquito events hook, and the front end for this application is already designed. So the link to this GitHub repository is going to be in the description below this video. So you can pretty much just go to the repo and see the rest of the code for the styling and also for the hook that we're going to be writing in here as well. So the first thing that we need to do is to import Tezos toolkit, and we're importing this from the Taquito library. We're also going to be importing this library called the polling subscribe provider, which is a method that is going to allow us to poll or to listen to events on the chain. We're going to import use state and use effects as well. And then we're going to also have our use Taquito events method. So this use Taquito events method is what we're going to export that we're then going to use on the front end of our application. Then we have our RPC URL. So the RPC URL is the RPC that we're going to be pinging or using to connect to the blockchain. And then we have the contract address, which we're going to update shortly to the contract address that we've gotten from our newly deployed contract. And then we create a new instance of Tezos first by calling new Tezos toolkit and then passing in the RPC URL that we want to use to connect to the chain in here. And then we're going to have this state. So the state here, I'm calling it number on screen and setting number on screen. I have this number to add here. So the number to add is the number that we want to add to the stored value. And the stored value is the number that is already existing in the storage. And then we also have block hash here. So the block hash is just for us to get the hash of the block that is the newly created block on the chain. And then we're going to have a use effects function that basically calls this method called get contract events when the app loads. We're going to use the Tezos instance, and then we're going to use these two methods from the Taquito library, setStreamProvider and getFactory, to basically listen for events that are happening on chain. So the polling interval milliseconds is 1,500 milliseconds. So basically every 1.5 seconds, we're going to be pinging the chain and trying to get whatever new events that has happened on chain. And now we're going to create our get contracts events method. And our get contracts events method is an async method. And so we have our try catch block here. And essentially what we're doing is that we're subscribing to events that have got this tag called add. Remember that we defined our add tag when we wrote our smart contract earlier. And then the address that we're also listening on is the contract address in here. So again, we're going to update this shortly. And then we're subscribing to get the data coming from the chain. And then we have this callback method that is going on in here as well, which basically returns data that is being received from the chain. And then we're going to get out the number to add, the stored value, and the block hash from the data object that is being returned from the chain. And again, if there are any errors, of course, we'll just simply log that out. And then finally, we're going to return the number on screen. So we're setting, remember that we're setting number on screen here, we're setting the state. So once the state is set, we're simply just going to return that value so that our UI can consume it and display it. Now with that done, we're going to update the contract address here. So let me go back to our SmartPy IDE to pull up the contract address. So here's our contract address. I'm simply going to copy and I am going to paste in here. And now in our index.tsx file, all you need to focus on is the fact that we're bringing in number on screen from our use Taquito events hook. Remember that use Taquito events was created here. We created this hook and we're returning number on screen. And all you have to do is pull that in here, number on screen, and then we're going to pass that to our events component. You can find all of this code in the GitHub repository in the description below, which is simply going to display all of these values on screen. Now let's look at what this looks like on our front end. Now if I go to the front end of my application, we can see number to add, stored value, and block hash, which are basically the three values that we're trying to get out of the event that is being emitted by the smart contract. And so to change these values, I'm going to go to Better Call Dev, again, our smart contract explorer for Tezos, and I'm going to paste our contract that we originated a few minutes ago. So if I go to storage, you can see that the value that we have here is 1. Remember that while we're deploying our smart contract, we initialized the storage with the value of 1. So I'm going to go to interact, which is actually what we want to do. And we have the add entry point here, and I'm going to say 10, right? So this means that the number to add is going to be 10, and the number in the storage or the stored value should now be 11. So I'm going to click execute. I'm going to click wallet, and I'm going to sign into Temple. I'm going to confirm the transaction. And once I confirm the transaction, I'm going to go back to my UI. And you just need to wait for a couple of seconds so that the dApp polls the blockchain to update this value. And as you can see now, the value has been updated. So number to add is 10, which is what we added. And now the new stored value is 11. And it also gives the block hash of the newly created block that contains this transaction on the blockchain. And this was a very simple example to demonstrate how events work on the Tezos blockchain using SmartPy. To learn more about events, go to docs.tezos.com and search for events.